So I start with a quote from a famous philosopher and logician about 100 years ago. Ludwig Wittgenstein, he said, "The limits of my language means the limits of my world." And what has that to do with poem languages? So he meant that for natural languages, but it actually also applies for poem languages. So what you can build with the language is influenced by the language. And if you look at the evolution of poem languages over the decades, starting with the Semler language, going over C and all kind of other things, you will see that as better the languages became, as better the applications which are built on top of those languages. And we at Aptos don't want that you have any limitations coming from Move. So that's why we are looking to make the even good language, already good language Move even better. And the environment, not only the language, that means the tools and the frameworks and so on. And that's what I would talk about today. Okay, so I would claim, we can argue about this, but I assume most of you agree, that's probably why you are here. Move can be already considered to be one of the most advanced, if not the advanced, smart code language on the block, so to say. And why is that the case? So let me start with the safety aspects of Move. So we have bytecode verification, which is a very important feature. What is bytecode verification? It basically, when you deploy the code to the blockchain, the code will be verified for type correctness, for reference safety, and for other aspects. So even if someone comes, you have compiled code and kind of patches your code, some malicious actor, doesn't help because the bytecode, when it's deployed, is verified. Not only the compiler does the type checking, but also the runtime on blockchain. This is an extremely unique feature. You don't find it in any other blockchain. So that's one aspect of safety in Move. Another one is the integrated specification language in Move, which is supported by the Move prover. So you can do formal verification with Move. So why formal verification, or what is good with formal verification? I want to cite another famous guy, Edgar Dijkstra. I don't know whether you know who that is. It's a pioneer of computer science, which created a lot of the algorithms we are using today in the 70s. And he famously said, with testing, you can show the presence of a bug, but you can't show the absence of a bug, because testing is never complete. With formal verification, you can actually prove the absence of any bug in your code regarding the property you have specified. So that's a very powerful, although not very easy to use technology, which we have in Move, and no other Move flavor supports that, and smart contract languages also usually don't support that. Now let me go to some more down-to-earth features which you expect from modern languages, and Move has them all. Let's start with type inference and generics, which you find in Move. You don't find them in Solidity, by the way. Let's look at higher order functions, linear types, and memory safety. I'm sorry. Why is this going? Okay. Okay, higher order inline functions, linear types, and memory safety. Features in Move which allow you to write safe and very productively code. And particular linear types and the memory safety of reference safety and so on are unique to Move. And maybe you find them also in Rust, but in no other languages. And then there's a lot of more stuff in Move. I don't really want to talk about all the details, no time, but you probably heard about it, like upgradability, for example, modular encapsulation, etc., etc. So Move is just a quite modern and quite powerful language which has everything you would expect and a little more. Okay, from the language, let's look at the frameworks. So a language alone doesn't help you. You need frameworks together with the language, which basically give you building blocks and solutions to create your applications. You don't have to reinvent the wheel. And the frameworks or libraries, how they are sometimes also called, are pretty sophisticated on Aptos. So it starts with objects and digital assets, which are the building blocks for you to create your data structures on chain. But there are also some extraordinary features which we recently added. For example, safe randomness is a pretty cool feature. You would think having a random function in a poem language is a simple thing, and it is a simple thing in a poem language, but not on a blockchain, because execution of a blockchain is fully deterministic. So how do you define randomness? Plus, there is the danger that someone can bias the result of the randomness for its favor of its own outcome in a game or so. So there's a lot of work which we put into that feature, and we think it's safe and it's working. Another pretty exciting feature are aggregators, which allow you to basically execute workloads in Move on Aptos, which look sequential, but they're actually executed in parallel, so via block STM. It's a very, very magical feature, and I can't tell you how it works, so I know roughly how it works, but it's pretty cool. So there's a lot more in our frameworks. Again, I don't have the time to go over that, and when you work with Move, you will see how it is. Okay, now let's talk about the tool set. So we had the language, we had the frameworks, and now the tools. Again, just the compiler is not enough. You need more to work with the language, and we are constantly extending the tool set for Move. So I talked already about the Move prover, which is there since a while. But there is also, for example, IDE support for the two popular IDEs on the world, like Visual Studio Code and IntelliJ. And there is other basic functionality which you would expect, like a CLI from which you control all things you want to do with Move, a unit testing framework, and a documentation generator. So each of those things I could give a talk by itself, but again, not that much time. Okay, so we talked about how great Move is today. How do we make it greater? And what is in store? And what's the new features in the second half of 2024? So the first thing is, in my mind at least, the Move 2 language edition, which adds a couple of things to Move, and I will show you examples how it is. And that is based on a new tool, the new Move compiler, which we built in the last year, over the last year. The Move compiler, or why do we build a new Move compiler? Because we want to have a unified architecture to extend the prover and the compiler, and it's now basically the same tool integrated in the same kind of building blocks. And yeah, so that compiler, by the way, was in beta, you might know, for a couple of months now, but today, basically, we're declaring it to a general usage. It goes out of beta. You can use it for your development as much as you want. Another feature which is coming now very soon, it's already implemented, it's currently prepared for release, Aptos Intents. So Aptos Intents allow you to define logic for transactions on client side without the need to add an anti-function to the contract. Or you can also even define logic for transactions which call different functions if you're not the owner of the particular contract, as long as you have the permissions to do so. So Aptos Intents is pretty cool. What we added recently is the preparation of a new feature in Move, basically dynamic dispatch for fungible assets, a special case, which is pretty important for DEXs and for other DeFi applications. And yeah, so we have always said, or some people said always, dynamic dispatch is dangerous, and we know it's dangerous, but we make it safe. It is basically safe dynamic dispatch, and that will be also supported in Move 2 in a general way, not only in that special case. Now, together with the new Move compiler, we are also shipping in the new Aptos CLI the Move linter. So the Move linter will tell you bad usages of problematic usages of Move and give you warnings. It's optional, you can run it. The Move linter is in an early stage, so but basically the architecture is set up, and we're adding rules as we, on a daily basis, basically, or as security and other feedback from you and so on tell us. And the Move decompiler, which we already shipped earlier this year, basically allows you to take the code from chain and present it into readable source code, which is also extremely unique. So in Ethereum, you need either scan or other approaches to reason about the Move code or the code which is actually deployed on chain. With Move, you can create source code from the bytecode. All right. Now I'm coming to the actual core of the talk, Move 2, and why Move 2 makes Move even better. And you can basically separate those new features of Move in two categories. Some of them is just syntactic sugar. Just sounds not so exciting, but I think it's actually pretty exciting. What it means syntactic sugar, you have like ways to easier annotate certain things. The code becomes more readable, easier auditable, easier writable. And features of this category on this list here are method syntax or receiver style notation and index notation. We will see an example in a second. And then there are enum types. So this is different than the tactic sugar. This is really giving you new power in your hands to do things which you couldn't do before in Move. And again, I will give you an example. Basically, enum types allow you to have variations of your data layout. One major use case for enums is versioning. So if you have like a version 1, version 2 of your data, you can do that with enum types very naturally. And last but not least, what is available also today is package visibility, which replaces or augments friend visibility and will make your contract safer if you use it, because we see that a lot of people declare unnecessarily public functions. Public functions are problematic in your contracts unless you actually write a library. So the package visibility solves that problem. I'm sorry. So the right side here, you see what's coming soon or coming next. And I think I should have walked here, then you can see this better. So there's quite a number of things which are currently in early implementation or later implementation, design phase, and so on. One of the most exciting features here is storable closures. So that's the generalization together with safe general dynamic dispatch for the fungible asset dynamic dispatch I was mentioning before. So this allows you to have basically function pointers together with partial lists of arguments stored on chain, and then get them out of the storage and execute them. Another feature in this category of what's coming very soon is resource access control, which allows you to restrict what an entity can actually read or write, which resources can read or write. Traits are coming. So if you know a little bit about Rust or C++, it's a powerful feature to write generic functionality, like ordering or crypto-algebra or something like this. And then last but not least, what's installed is enhanced reference semantics. And if you have used Move in more advanced scenarios, you probably came along the problem that you can't return a reference to global storage from a function, which is very restricting and limiting, and we will remove that restriction. Now let's quickly go over look and feel. No? So here you see, without method syntax and index notation, some random fragment which I copied and pasted out of the framework, of the Aptos framework. Someone want to push some data, the metadata, on a vector, but the vector is stored in a global resource, and there is a field, the packages field, which contains the vector, so you have to write something like this, and boom, with method syntax and index notation, that reduces to this one-liner. Another thing is the enum types for versioning. Let's say you started defining with your data V1, I call it here, and you had just one field, but then you figure out, oh, I need another field. And unfortunately, the upgrade policy today doesn't allow you to add a field to a structure, because that's not compatible with existing storage. So what you have to do is define a new resource type, and now you have to maybe define some upgrade logic for that, and the upgrade logic unfortunately requires a signer as a parameter, and you need to get the signer down to that code where you want to do the upgrade. It's just awkward. No? And also, by the way, not safe to pass a signer to that code. So with enums, you would do that like this. This is one type, and it stays the same type. You start with your variant V1, and you can use it just as a struct type. But then you figure out, oh, I need a V2 of this data, so you just define a new variant, which has the additional field. And the upgrade logic doesn't require any signer more. And when you look closely, you see here a match statement. So you have everything which you know, perhaps from Rust and enum types, you have that also, and a bit more in the enum types of Move. All right, so that's what I had to say, and let's look at the timeline. So right now, you can do it right now. You call Aptos, update Aptos, for getting the newest Aptos CLI. Then you say Aptos move compile - move to, and then you will have those features on the left side here: method syntax, index notation, enums, package visibility. We're expecting to ship in Q4 until the end of the year the storable closures and access control, and then early 25 the traits and the enhanced reference semantics. So this is all together Move 2, but it will be basically 2.0, which we are shipping today, 2.1, 2.2, as we are proceeding. Thanks.